everyone. In this sixth lecture of Internet of Things, we will discuss communication APIs. So till now we have discussed the component of IoT. Uh, Mainly we have at the end node sensors and some computing device which we call end node, and they are connected with some intermediate nodes like the gateway, and at last there are some central node like servers. So between node to node or node to end communication or node to edge communication, we have different protocols. Uh, Again, in the last lecture, we have seen the communication mode like client server mode, publish subscribe mode, uh, push pull, and exclusive pair mode. In this lecture, we will discuss the API, the communication API. Once we uh, decide communication protocol, communication mode, then we have to think about how we can design the API so that the different computing device can interact with each other. So basically, we will learn here the two different kinds of APIs. That is, the one is the REST API, another is the uh, Websocket Based Api. REST APIs is a full duplex, as we have seen in the previous lecture. That REST API basically based on HTTP, which is the full half duplex, and WebSocket is the full duplex communication. So let's begin with the REST-based communication API. REST stands for Representational State Transfer. Representative is a architectural principle by which you can design web service and the web API that focus on systems resources and how resources state are addressed and transferred. So there are four principles of REST API. The first is identification of resources by some identity. So REST APIs follow request response cycles. Here client server is separated, decoupled fully, and it follows the request response communication. The REST architectural constraint apply the component connectors data element within distributed hypermedia system. Again, the hypermedia is important term. That means one media can give access to the another media through the links. For example, we have HTML page, and there we have embedded links for some images. So using that links or links for some forms. So when we click those links, it send request to another resources. This type of media is called hypermedia. So in this block diagram, we can see here the REST architecture, and at the client, the communication is started by the client, HTTP client. From here, the communication as REST is based on the HTTP protocol. So communication is started by the client, and in the intermediate block, we can see here the packets. The communication is started by using some HTTP command or HTTP verb, what do we call it? Like get, put, post, and delete. For example, get is used to send the request, put is used to update some request, post is used to create some request, and then delete is used to delete some request. And in the payload, HTTP packets bottom, payload is in the form of JSON and XML. JSON is more popular in the making RESTful architecture. XML is more popular in SOA oriented, means service oriented architecture. Then at the next block, we can see HTTP server, where authorization is done, authentication and authorization is done, whether the request sent by the client is accessible to this particular client or not. So the server has to identify the client, and based on that identification, it decide whether the requested resource should be given or not. So this, or there can be a web server at the HTTP server, web server that gives the HTML and HTML response. And in the fourth block, we can see the fourth important part is the resources, and each resources has some unique identity that we call the URI, unique resource identity. The resource is again transferred or sent in form of some representation. It's not that resource are heterogeneous. A resource must have some representation, and that representation is sent to the client. So we have some REST constraint. The REST architectural constraint are followed. The first is the client server. That means to establish a REST, we have to follow the communication model for client server as we have discussed in the previous lecture. Here, the client server model enables us that it is decoupled. So at the client end, development can be carried out quite independently with respect to the server end. The principle behind the client server constraint is separation of concern. As it is written, separation of concern. For example, client should not be concerned with the storage of data which is concern of the server. Here it is explained further that for example, client should not be concerned with the storage of how data is stored on the server. Client has simply has to access the resource. They are it is unaware of how this resource is stored in the backend. Similarly, the server should not be concerned about the resources. Similarly, the server should not be concerned about the user interface. So, server simply send the resources, how it is arranged and formatted. That is the job of the client. Server has nothing to do with that, which is concern of the separation. Separation allows the client server to be independently developed and updated. This is the most important thing, that this separation allows client server to be independently developed and updated. Next point is stateless. As I have said, there is half duplex, so each time the connection is closed. And stateless means, as we have seen in the previous lecture, that the particular request response cycle is independent of all other request response. So each request from client to server must contain all the information necessary to understand the request, and cannot take the advantage of any stored context on the server. That is what we mean stateless protocol. The session kept is entirely on the session. The state is kept on entirely on this client. So one important question is how two different requests can be connected, can be linked. It is through the session, as we see in a web like reservation system or some multiple form fill up. So as it is stateless, so the question arises how these multiple requests are related, or how one request are. It is by session, and these sessions are created by with the help of cookies. Third important point constant is that REST. This is the advantage of REST framework, that it is cacheable. Cacheable means cache constant requires the data within the response to a request to be implicitly or explicitly labeled as cacheable or non-cacheable. First, every resource must be labeled whether it is a cacheable or not. Explicitly labeled cacheable or not. If the response is cacheable, then a client cache is given the right to reuse that response data for later equivalent request. Caching can partially or completely eliminate some interaction and improve efficiency of scalability. So caching basically improved our efficiency and scalability. Layered system. Again, the REST architecture is a layered system. Layered system constrains the behavior of components such that each component cannot see beyond immediate layer with which they are interacting. For example, a client cannot tell whether it is connected directly to the end server or to an intermediate along the way. System scalability can be improved by allowing intermediate ready to respond the request instead of the end server without client having to do anything uh, different. So in fact, the client is not aware of the server architecture. Server can be broken into different parts. Server can be uh, broken into different apps or different even different web server. So, but the client is not aware. For example, we can give the example. For example, we can give the example of Google documentation or uh, web-based application. Uh, it is possible that there are multiple apps or multiple web server are uh, giving the service, but the client is not aware of that. So it is a hidden type of things, totally decoupled. That is the advantage of RESTful architecture. Uniform interface. Again, the interface should be uniform. Uniform interface constraint required that the method of communication between client and server must be uniform. It is not that frequently we change this way of interaction. Resources are identified in request by URI. URI used to identify the request and are themselves separate from the representation of the resource that are returned to the client. When a client holds a representation of the resource, it has all the information required to update or delete the resource provided the client has required permission. Each message includes enough information to describe how the process message. Basically, this is simple thing that we have already explained. Means the interface has to be kept uniform. It is not that some clients are using one way of interface and another client are using another way of. There must be one common way of interaction, and that is also described in the documentation of the RESTful architecture, which is very important. And again, this should not be frequently changed. While if we have to make some update, it is made under hood, but the way the interface of interaction, uh, for example, by giving the verb and should be kept constant. Code on demand. Server can provide executable code or a script for client to execute in their context. This constant is the only one that is optional. Now come to another API, that is the Websocket Based Api. As we have already seen that Websocket is a two-way interactive communication system. So Websocket is an advantage is an advanced technology that makes it possible to open a two-way interactive communication. It is two-way interactive communication system between user browser and server. With this API can send message to a server and receive event-driven response. Server and event-driven response without having to call the server for a reply. Calling the means sending the request, then making the connection, then sending the data. This is not required. Once the connection is established, the message can be sent in both the directions continuously without the overload of extra putting a header that is put by the TCP/IP. The connection is kept open in the WebSocket based communication. That's why, for example, it is both way communication. That's why we find its application in the chatting, and if we have to fetch some real notification, we use WebSocket for the notification, because notification is sent by the server to the client without any request. So to make a notification system, we need WebSocket based technology. In this figure, we can see the client request setup WebSocket connections, the server accept the request, then the data are frequently sent and received, and at last the client send the request for closing and the server close the connections. So here are a few important features of WebSocket API. WebSocket API use bidirectional full duplex communication between client servers. So as we have seen in the last lecture, it is exclusive pair communication model. Next, unlike request response APIs such as REST, the WebSocket API allow full duplex communication and do not require a new connection to be set up for each message to be sent, as we have seen in the previous figure. WebSocket communication begins with the connection setup request sent by the client to the server. This request called the WebSocket handshake is sent over. So remember this important thing, that the connection is made first over HTTP, then it is kept open, then it is again become stateful. While the HTTP is stateless, the WebSocket packet transfer is done using a stateful communication, but the communication is established over HTTP. So it has also advantage of some HTTP. If the server supports WebSocket protocol, the server responds to the WebSocket handshake response. After the connection is set up, the client and server can send the data message to each other in full duplex mode. And at last, WebSocket API reduces the network traffic and latency, as there is no overhead for connection setup and termination request for each message. WebSocket is suitable for IoT applications that have low latency or high throughput requirement. As we know, in file network, for example, message generated by application and below layer protocols put some header. So when the connection is stateless, every time you make a request, the lower protocol level put some header. That is not in the case of WebSocket. As the connection is kept open, we do not. The frame is the packet is lightweight, and therefore it can use for real-time communication. With this, we finish this lecture.